The idea of searching the ocean floor is a huge undertaking, so we want to show you the difference between a couple of technologies that are likely being used in the Indian Ocean. I want to introduce you to James Coleman. He's a senior hydrographer with Teledon Rizan, and he's going to show us first what a hydrophone does.
Exactly. So this is a hydrophone. A hydrophone, put simply, is an underwater microphone. It's a device like this, either strung together in a tail that they tow behind the boat, or dipped over the side, or put on autonomous vehicles that they're going to use to listen for that underwater pinger.
All right, and so this is just another example of it, but how wide, how long can it hear?
About 5 miles, based on the frequency that we're looking for in that pinger.
Okay, so that sounds like a lot of mileage, but it actually isn't underwater. So let's just say, though, if you do get closer and you are over the field of debris, or you're looking for it after you get closer, you would go to sonar.
Yes, and you're going to use a sonar to map out what's on the seafloor, map out that field of debris. And this is an example of a sonar. The sonar is going to emit sound itself instead of the hydrophone, which is just listening for that pinger. This is going to emit sound, and as that sound comes back off the seafloor and it receives it, it's going to interpret it and build up a 3D map of what's on the seafloor.
All right, and so let's take a look at what some of that data looks like, starting off by taking a look at what's coming in from the hydrophone, because that is basically what it's hearing visually, right?
Right, and you could just put a headset on and you could listen to the hydrophone and listen for that once per second click. Or you could look at it visually, and this is a spectrum of what the frequencies are on the ocean. It's just ocean noise. If that pinger were here, we'd see a spike right at that pinger frequency, right up between 30 and 40 kilohertz.
All right, so that's one thing that's helping us. The other technology is the sonar and what the sonar is picking up.
Right, and as I said, the sonar is emitting sound in order to build up a map of what's on the seafloor. So we're getting back an image of all the different debris that are on the seafloor as that sound comes up. We have a 3D point cloud as well as an image. And we can use that to build slowly a map of what's on the seafloor.
And how long does this take going through and searching like this?
It's very time consuming, particularly because you have to get these sensors down deep near the ocean floor, which in a full ocean depth in 5,000, 4,000 meters of water is very difficult.
And that's part of the reason why it's taking so long, as they're searching through these super deep waters of the southern Indian Ocean.
Yes, exactly.
So this is just a little bit of a visual of what they're likely doing in those waters, trying to see if there's any debris down there. This technology that we are looking at here in the Santa Barbara Harbor. I'm Stephanie Elam.